We're going to be picking back up at week 8 notes. So week 8 notes is a big section of what you're going to be learning over the next few weeks, and it has to do with something called a quadratic. So quadratic is just a word to represent a different type of graph versus what we were working with before. So all we've done up to this first point at that first test, the last class we had together, was linear functions. Okay, a quadratic function is going to look like this when graphed. It is called a parabola, or it might be upside down. Okay, two different types of parabolas, a positive and a negative parabola. That was noted in the week 7 notes, but due to the extended spring break, I'm eliminating that because you don't really need to know much more than what I'm just showing you right now, and we will get into graphing it next week anyway. So the other thing that was learned in last week that I again skipped over is what a quadratic function looks like. So I'm just going to add that to the top of this set of notes. To be a quadratic, you have to have an x squared somewhere in your function. That's really all there is to it. The standard setup for a quadratic, and I don't like to show this because it does tend to throw some people off, but it's what I just wrote here in red. ax squared plus bx plus c, where a, b, and c are just numbers. Okay, so ax squared plus bx plus c, where a, b, and c are just numbers. Let's say they're all 2's. It would be 2x squared plus 2x plus 2. The biggest thing you need to take note of in this setup is that there is an x squared and there is an x. When we were doing linear functions prior to this point, you only had an x inside of your equation. Now we're adding in an x squared as well. So this entire first page of notes is just going to be a little bit of a review for you guys, hopefully reviewing the distributive property, which is something you needed to know for the last test, but expanding it out and making it just a little bit more challenging to lead into what we're about to do for the week 8 notes. So just again, a review of the distributive property. I'm going to start by distributing these through. Now remember, the distributive property has everything to do with the parentheses that follow the multiplication. So this 3x is being multiplied by the 2x, the minus 4, and then it stops because the parentheses end after that 4. So I'm going to distribute that through. 3x times 2x is going to be a 6x squared, and 3x times a negative 4 is going to be a minus 12x. Okay, now I have this negative 2. It's a completely different distribution now. Negative 2 is being multiplied by the two things that go after that. So negative 2 times that positive 2x is going to be a minus 4x, and then negative 2 times a negative 4 is a positive 8. I'm not entirely done. I now need to simplify this down just like we always do. If you have like terms to combine, you are going to combine them. So the 6x squared does not have any other x squared to combine it to. I'm going to bring it down. The negative 12x and the negative 4x combine to get me negative 16x, and then my plus 8 comes down. And notice this is the exact setup that I went over with you over here in the beginning, that ax squared plus bx plus c format. So your answer for question number 234 is a quadratic. All right, now just something else that I'd like to review with you that we did already see in that question, but I'm just going to make sure it's very, very clear, is going to just go over here as a little side note. There is a huge difference between x times x and x plus x. X plus x we've done a lot with. It just looks a little complicated, but when I look at it in terms of having those ones in front, even though I don't see them, they are there. It's 1x plus 1x, which is 2x. If I have one of each of them, add them together, I have 2x. Now x times x, when you get into multiplying, and we will look into this in the future, but it all has to do with your exponents. I have x to the first times x to the first. I have a total of x squared. X times X is always going to get you an X squared. I don't know if you noticed because I did it quite quickly up here, but we had 3X times 2X, and that X times X got me this X squared right here. When we were combining like terms, so this that I'm underlining again, negative 12X minus 4X, technically adding them together, but it's a subtraction because it's negative, gets me negative 16X. I just combined the first numbers, whereas when you multiply them, it's all about the exponents. All right, so let's take that to practice with the next one. Now, believe it or not, question 235 is identical to question 234. It's just written out differently. So I'm going to try my best to show this to you on an iPad, showing this distribution. So if you look back at 234, the first thing we distributed through was 3x. That's exactly what we're going to do for this one. So the way that this one is written out, it's telling you that everything in this first set of parentheses needs to be distributed through to everything in the second set of parentheses. So you start with the 3x and you distribute it through to everything in the second set of parentheses. So once again, I have 3x times 2x, which is 6x squared because of that x times x idea. 3x times negative 4 is a minus 12x. Now, like I said, everything in the first set of parentheses needs to be distributed through to everything in the second set of parentheses. So now I have that negative 2 that needs to be distributed through. I'm just going to draw the lines along the bottom so it doesn't get too confusing. Okay, but I have negative 2 times this positive 2x right here, so that's a negative 4x. And then negative 2 times that negative 4 at the end is a plus 8. And notice we end up with the same thing that we got in the last one. When I go to combine like terms, I get the exact same answer. Now, why would I make you do the same question twice? It's going to be set up more like 235 in the future. Okay, so if we look ahead at 236, it's kind of that same setup. I'm going to do that identical procedure. So this first set of parentheses has 2 terms in it. They both need to be distributed through to the 2 terms in my second set of parentheses. So I start with the 4x and I distribute it through. 4x times 4x, first 4 times 4 is 16, and x times x is x squared. Then 4x times 5 is plus 20x. Then I have a negative 5. That negative 5 needs to be distributed through. Negative 5 times 4x is a negative 20x, and a negative 5 times a positive 5 is a negative 25. Same idea as the last one. When I'm at this step, all I need to do is simplify by combining like terms, but I have a positive 20x minus 20x. Those are going to cancel each other out and leave me with nothing for x terms. So I have 16x squared that comes down, and minus 25 that comes down. Believe it or not, that is still a quadratic. It just is missing that bx that we had in our ax squared plus bx plus c standard quadratic form. That's okay. It is still a quadratic because it has that big idea we started with. It's got an x squared. All right, so the big idea of what we're going to be doing today is we're going to be given something like these answers that we ended up with in these first few examples, and we're going to end up working backwards to end up back here. So essentially what we're doing is we are undoing the distributive property. In order to do that, we have to do something called factoring. Now, I know some of you have already mentioned to me that you know what factoring is. There are several different methods of factoring and different ways of doing them. If you are unfamiliar with the way that I am doing it, you can absolutely give your method a try and just make sure you're getting the same answers as me. If you are not, then your method's not working, okay? So please just make sure that if you do decide to use your own method that you've learned in high school differently or in a previous college math class, not a problem at all. Just make sure you're getting the right answer. Now, before we dig into those methods of factoring that I just brought up, there's some background knowledge we need to know that's hopefully going to be a little bit of a mathematic review for you. So first is, what on earth is a factor? So factors are numbers that can be multiplied together to get a different number. So for example, 237 is asking about the factors of 16. Think about think about sets of two numbers that you can multiply together to get yourself 16. I always like to start at 1. It helps you organize your thoughts a little bit, but 1 times 16 is my first pair of numbers that can be multiplied together to get 16. So 1 and 16 are factors of 16. I also have 2 and 8. 2 and 8 are factors of 16 because 2 times 8 is 16. My last set of factors for 16 is 4 times 4. So 4 is a factor of 16. All right, part B, kind of the same idea, but list the factors of 8. Again, try and keep yourself organized. I always start at 1 and then just work my way up. So 1 times 8 and 2 times 4 are my only factors of 8. Yes, I know that 4 times 2 and 8 times 1 also work. If you flip-flop those, you don't need to list them. It's still the same numbers you're essentially listing. All right, now C says, what is the greatest common factor between 16 and 8? So I'm going to go back up to parts A and B and try to find what they have in common. And then it's asking for what they have in common that is the greatest. So if you look at your two lists of numbers for A and B, the biggest number that they have in common is 8. So 8 is the greatest common factor, which we are going to refer to as the GCF. Just taking the first letters of greatest common factor. All right, now doing that same thing again. What is the greatest common factor between 27 and 54? Take a second to list out the factors of 27, list out the factors of 54, and try to find the common factor. I'll give you a second to try and figure that out. If you need to pause, absolutely go ahead and pause. You should get a GCF of 27. Something that's kind of a nice shortcut that maybe you've noticed with the last two greatest common factor examples that we did is looking at the smaller number. So going back to part C, the smaller number between 16 and 8 is 8. The biggest number that can go into 8 is 8. So if 8 also goes into your other number, it's got to be your greatest common factor because nothing bigger than that smaller of the two can go into both of them. So same idea with 238. Between 27 and 54, 27 is smaller. So that means the biggest factor of 27 is 27. If 27 also goes into 54, which it does, it has to be their greatest common factor because there's no factor bigger than 27 that goes into 27. Okay, so using what I just said again, because I know it's kind of a lot to take in, 239, what is the greatest common factor between 2xy and 4x squared? Ignore the letters for now and just look at your two numbers. I have 2 and 4. 2 is the smaller of both of those numbers, so the biggest factor that goes into 2 is 2. 2 also goes into 4, so my GCF is going to contain that 2. It has to. It has to. Sorry. Alright, so 2xy and 4x squared. I want to look at this x squared for a second and go back to what we talked about in the beginning for what that means. X squared means x times x. So really what I'm trying to figure out is what xy, what xy and what xx have in common. Xy and xx have just one x in common. So your overall total GCF is 2x. That's what you need to know about GCF in order to do one of the methods of factoring we're going to be looking into. And again, we'll get more practice with it when it comes. It's just some background knowledge. All right, last little bit of background knowledge for a different type of factoring is perfect squares. So perfect squares are something most people are familiar with. We just don't really put a name to it. Perfect squares are the answer you get when you multiply any number by itself. So for 240, when it says to list the perfect squares, what that means is just do whatever the result is of 1 times 1, which is 1. Then the result of 2 times 2, which is 4. These are all perfect squares because it's the result you get when you multiply something by itself. So 3 times 3 is 9. 4 times 4, 16. 5 times 5, 25, and so on. Now this list does go on. You're not going to really need to know anything higher than 10 times 10 being 100. So just get all those numbers written down. And I will tell you, it will benefit you greatly in the future with factoring to have those numbers recognizable. So what I mean by that is if you see an 81, you know that it's 9 squared. If you see an 80, you know it's not a perfect square. If you see 49, you know it's 7 times 7. Okay, some of us are really good with our multiplication facts and some of us are not. You always have your calculator as a backup to check. Even if you're thinking it is and you're unsure, just plug it in the calculator to make sure. Okay. Next one, what makes a variable a perfect square? Again, going back to that x times x. If you multiply x by itself, you end up with x squared. Okay, that's the one you're going to see most often. I'll show you a different one. If you do x squared times itself, x squared, it'll end up getting you x to the 4th. If you keep going with all of these, x to the 3rd times x to the 3rd is going to get you x to the 6th. Notice what's happening with these exponents. So what makes a variable a perfect square is that the exponent is even. Notice it was 2, 4, 6. The next one will be 8, 10, 12. If the exponent is even, it makes your variable a perfect square. All right, that was our intro. Now we are moving on to actually doing the factoring. So here's that setup again. This page we're going to refer to towards the end, but it's kind of like your cheat sheet for what type of factoring you're supposed to do and when. It's not helpful to you right now because you don't know the types of factoring we're about to get into, but this is definitely big for you to recognize right now. It's that standard quadratic setup. So ax squared plus bx plus c, and then something we already talked about briefly, but just give it a little star. Factoring is undoing the distributive property. So we started with distributing today, and like I said, we're going to be undoing that and working backwards using 5 possible different types of factoring. So you'll see all of them on this table here. We're going to go over them one by one, and like I said, this is just going to be a cheat sheet for you at the end. So I know you don't know what the grouping method is right now, but notice you'll have to do grouping when you have 4 terms. So that's really just the idea of this table, is to kind of help you out. It's like condensing all the information we're about to learn. All right, here we go. Next page. It's the first type of factoring we are going to learn is greatest common factor. Like we just went over is GCF. So the type of factor, to know when you're supposed to use this type of factoring, it's always going to be the first type of factoring you check for. And you're only going to use this type of factoring when there is a GCF to be accounted for. If you look at your expression or your equation and you don't see something that the terms have in common, you are not going to use this method. If it does have a GCF, you are going to use it. It's probably the toughest one to decipher when to use it, but honestly, it's just if there is one, you do it, and you always look for it first. Okay, so this box shows you how to do it. It's just supposed to spell it out for you if you're working on your homework and you forget how to do it, but I'm going to walk you through it like I normally would in class. So question 242. This method, or this GCF method, does apply to this question because if you look at your 2 terms, 3x and 9, they do have a GCF in common, and it is 3. So if I was just giving you the example that was on the first page, find the GCF between 3x and 9, you would tell me 3 goes into both 3 and 9. It is a factor of each of them, so it's my greatest common factor. The 3 has an x on it, but the 9 does not, so they don't have a variable in common for this one. Okay, once you figure out what the GCF is, what you're going to do with it is take it out of both of these terms. Now what I mean by that is divide it. You'll see what I mean once we work backwards again. But I'm going to divide both of those by 3, and then your setup for your answer, because we're actually almost done, is to take that GCF and then follow it with a parentheses and then actually do this division. 3x divided by 3, your 3's kind of cancel, or you can just write 1x. If you just write x, that's fine too. And then 9 divided by 3 is a plus 3. This is your answer. Okay, now like we said, or like I said I should say, factoring is undoing the distributive property. So if you want to check, you never have to check, but if you want to check, all you would do is redo the distributive property. We just undid it. If I redo it, I should end up with my exact answer. So when I distribute the 3 through, 3 times 1x is 3x, and 3 times 3 is a plus 9. Notice I end up with exactly what I started with. So it does check out. So see how dividing that 3 makes sense, because you're undoing this multiplying it through. You're just doing the opposite. All right, let's do it again for the next one. So between those two terms, 24x squared and 8x, I have to figure out if it has a GCF, and if it does, what it is. Sorry. So between 24 and 8, ignoring the variables for now, between 24 and 8, my greatest common factor is going to be 8. It's the biggest number that can be divided evenly out of 24 and 8. Okay. Now for my variables, remember x squared means x times x, so it just means there's 2 of them, but my 8x only has 1, so look at what they have in common. They have just a single x in common, so my overall GCF is 8x. Now I'm going to actually use that GCF to factor it just like I did in the last one. I start by dividing both terms by the 8x, and then I bring the 8x down with a parentheses. Okay, 24 divided by 8 is 3, and x squared divided by x is x. If you're not very familiar with dividing variables, think about it this way. Using that x times x, you have x squared on top, which is x times x, and you're dividing it by x. These two are going to cancel and just leave you with 1. That's where that x comes from. Okay, if you had, let's say, x to the 6th on top, you have 6 x's divided by x to the 3rd. You'd have 3 on the bottom. These 3 would cancel and it would leave you with x to the 3rd. That is a completely random example just to help you out with dividing. If you're unfamiliar with it, just draw out how many x's you have and it'll give you your answer. Okay, now this last part, 8 divided by 8, like we said, it technically cancels or leaves you with 1. Same thing with the x's. They technically cancel or leave you with 1. You have to put that minus 1 there. The reason for that is because of your check. So when I go over here and I go to check this, 8x times 3x minus 1. When I distribute the 8x through to check it, 8x times 3x is 24x squared. If I didn't have that minus 1 there, I wouldn't end up with the minus 8x that I need to be here. Okay, so I absolutely need to have this minus 1 here so that when I distribute the 8x through, I can check this out. If it wasn't there, it wouldn't check. Right, normally in class I'd have you try 244 and 245 on your own, so take a second to pause it right now and give those two a try on your own. If you're still struggling, I'm just going to go right ahead and keep explaining it to you, but definitely give some of these a try on your own when you feel ready. So 244, I need to figure out what the GCF is of that. The GCF between those two is x. So I'm going to divide each of them by x, and that puts my x out in front. You could think of your GCF as 1x. That's perfectly fine. These x's cancel and leave me with yz. These x's cancel and leave me with plus 2. And that's my answer. Again, you can check it off to the side. You can try to check it in your head just by distributing that x through. It does check out. All right, 245. When I try to find out if it has a GCF, it absolutely does. Between 2 and 18, my GCF is 2. And then this right here is an x squared, which means x times x. And my 18x only has 1. So to figure out what variable they have in common, it's just going to be an x. So now that I figured out what the GCF is, I'm going to divide all of my terms by 2x. Same setup, the 2x comes down and follow it with parentheses. Okay, 2 divided by 2 is a 1. Those essentially just cancel out or leave me with a 1. And then here's that same idea, x squared divided by x just leaves me with an x. This and this cancel. 18 divided by 2 is a 9, and those x's cancel out, so that is it, and this is my final answer. I can distribute it through mentally or off to the side to make sure that I undistributed correctly. 246, a little bit tougher. I have 3 terms to try and find the GCF between, but not too bad. First, look at your numbers. I have 3, 21, and 12. Hopefully you're thinking to yourself the GCF should be 3. Remember that trick I showed you in the beginning. If you look at the smallest number here is 3. The biggest number that can go into 3 is 3. So 3 has to be the greatest common factor between all of them because it also goes into 21 and 12. Nothing bigger will work. Okay. Now I try to see if they have a variable in common. My first term has an x squared, my second term has an x, and my last term doesn't have a variable at all. Because of that, that means they don't have a variable in common, and I'm good to go. So I start doing my GCF factoring by dividing all of them by 3. The 3 comes out in front, and I follow it with a parentheses. 3 divided by 3 is 1. You can put it there, or you don't have to worry about it at all. It's just going to come down as an x squared. Negative 21 divided by 3 is a minus 7, and that x comes down as well. And then 12 divided by 3 is a plus 4. Final answer. I could check by distributing. All right, now what I said in the very beginning of this page is that the GCF method of factoring only applies if you have a GCF. For this last example, between 4x and 5, nothing comes out of them. So technically, there's no GCF, and I want to be very, very clear. Please don't write what I'm about to write in red. Everything has a GCF of 1. Again, you're not writing what I write in red. If I divide each of these by 1, I could put that 1 out in front, but anything divided by 1 gets you exactly what you started with. That does not count as the GCF method. Taking out a 1 never qualifies. So when I write out no GCF, I mean there is no significant GCF that'll affect this. This answer is actually just 4x plus 5. You're not going to use a GCF of 1. That's all you really need to know about the GCF type of factoring. We're going to move on to our next type of factoring, which is difference of perfect squares, also known as DOPS. Same idea as GCF, just taking the first letter of this method, DOPS, DOPS. Okay, so you are going to do this DOPS method when you have 2 terms, and you have to have the setup that it is, titled. The difference, which means subtraction of perfect squares. There's the rest of it right there. So if you have the setup of 2 terms and they are subtracting perfect squares, you're ready to do this difference of perfect squares or DOPS method. So again, there's that box that shows you how to do it. You don't need to really look into that unless you don't understand it while you're working on your homework and you just need a step-by-step written instruction. I'm going to walk you through it though. So for 248, I notice I have 2 terms right off the bat. They are being subtracted and they are perfect squares. Remember that list of perfect squares we had in the very beginning. 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9. I'm just going to list them all out on the top of the screen for you. Just as a reference, again, you want to be able to recognize those numbers for this exact purpose, to notice if you're doing the difference of perfect squares method. Okay, so for 248, again, 2 terms, I have subtraction. 4 is on my list of perfect squares, and x squared is a perfect square because it has an even exponent. Okay, so 4 is a perfect square, it's on my list. X squared is a perfect square because it has an even exponent. Here's how you do it. It's actually a very easy process, which makes people forget it easier, so try and stick with me. Because they're perfect squares, what I'm going to do is take the square root of them. So a square root, what the square root is asking you, specifically I'm going to focus on the 4. The square root of 4 is saying what times itself will get you 4. So the square root of 4 is 2. Okay. The square root of x squared. What times itself will get you x squared? The square root of x squared is x. So the square root of x squared off to the side is x. The square root of 4 is 2. Okay. Now I want you to circle this. I know I said we're going to ignore the box. This is going to come into play for every single example. Your answer is always going to be written out in that exact form. 2 sets of parentheses, one with a plus and one with a minus. You're going to take what you got from your first square root and put it in the blank in the first 2 spaces in that setup. Then you take what you got in the second square root, which was a 4 for this one, or I'm sorry, in this case the square root of that is a 2, and we're going to plug those in right there. That's your answer. Okay. Now every single factoring problem can be checked by distributing. So I'm going to show you what the check for this one would look like, because it is a little bit different when you have the 2 sets of parentheses like that. So remember what we did. Very first thing that we did in the beginning of the video. When you have everything in this set of parentheses multiplied by everything in this set of parentheses, you take it term by term. So I'm going to start with this x and distribute that x through to both terms in my second set of parentheses. X times x is x squared, and x times negative 2 is a minus 2x. Then I take this plus 2 and distribute that through to everything as well. 2 times x is a plus 2x, and 2 times negative 2 is a minus 4. Now I know that's not exactly what we started with, but when you combine these like terms, a negative 2x plus 2x cancels out, and you get x squared minus 4, which does check. You never have to do the check. I advise you to do the check to make sure that you've done it correctly. All right, so 249, 9x squared minus 64. Again, I need to make sure that Dopp's method works. I'm going to revert you back just for a second to the Gcf method. When you're doing these problems, obviously this entire page is dedicated to Dopp's, so Dopp's is going to apply. The last page was dedicated to Gcf, so we kept doing Gcf. On your quiz and tests and all of that in the future, you're going to have mixed type of factoring all together. So with this example, 249, what you would want to do if you were just given this on a test or a quiz is see if it has a Gcf first. Between 9 and 64, there is no common factor other than one that goes in. So that tells you Gcf doesn't work. You would then see what your next method would be. Well, Dopp's is used when you have 2 terms specifically and you need the correct setup. Difference, which is subtraction, of perfect squares. Those are both perfect squares. They're on my list at the top of the page. So Dopp's method applies for this one. That's how I know I'm supposed to do it. A lot of people learn how to do the method, but they don't learn when to do the method, and it really messes them up on tests and quizzes. So please keep note of that too. All right, so I know I have to do Dopp's for this one, so I'm going to start my Dopp's method and get my setup going. Remember, 2 sets of parentheses, one with a plus and one with a minus. All right, the square root of 9x squared. Take it piece by piece. The square root of 9 is asking you what times itself gets you 9. That's 3. And then the x squared is asking you what times itself gets you x squared. That's going to be an x. So I'm going to put a 3x in the first section of both of these sets of parentheses. All right, now the square root of 64, what times itself gets you 64? That's going to be an 8. So I'm going to put an 8 in the beginning or at the end of both of these sets of parentheses. And that's your answer. Again, you can check it. I'm not going to go through the check for all of these. It is on my answer key. If you want to see how the check would be done, go to Blackboard content And you'll see my answer key on there. All right, next one, 250, same idea. You would want to see if there's a GCF to start. There isn't one, so what you do is you see if DOPS applies. I have the difference, which means subtraction, and both of those are perfect squares. So I'm going to jump right in and start by doing my difference of perfect squares method with my two sets of parentheses, one with a plus, one with a minus. All right, the square root of 81 is 9, and the square root of x squared is x, so all together in the first space of my setup is going to be a 9x. Now for 49y to the 6th, we haven't looked at an exponent that big yet. So 49y to the 6th, hopefully the 49 is pretty easy. The square root of 49 is 7. Now the y to the 6th, I'm going to bring you back up to the top and want you to look right here. It says to take the square root of a variable, just divide the exponent by 2. So 6 divided by 2 is 3. So that y to the 6th is going to become y to the 3rd. Here's y. When I have y to the 3rd times y to the 3rd, remember what we did in the beginning today. If there's 3 here and 3 here, that's going to get me 6 total. So y to the 3rd times itself gets me that y to the 6th that I needed to become. So 7y to the 3rd is going to go in this space. We'll do one more like that. So if you didn't get it right off the bat, we'll use that dividing it by 2 again. For this one, for 251, again, you'd want to see if it has a GCF. It doesn't, so I continue on to see if it works with the DOPS setup. I have the subtraction, and those are perfect squares because they have even exponents. So I jump right in and I start doing DOPS, and I set up with my two sets of parentheses, 1 plus, 1 minus. Now the square root of x to the 8th, all I do is cut my exponent in half. Half of 8 is 4. Same thing with y to the 12th, cut that exponent in half, I get y to the 6th. So x to the 4, y to the 6th, x to the 4, y to the 6th. Okay. For now, yes, that is your answer. What I want to give you a little prelude into what we're going to be doing in the future is this right here. Some of you may have already noticed, but it can be factored again. So don't worry about it for now. You're definitely not going to see this on your week 8 homework quiz. But this is DOPS again. You have the subtraction of perfect squares because my exponents are even. So again, just to show you what you're going to be looking into in the future, you can factor that again, plus and minus. The square root of x to the 4th is x squared. And the square root of y to the 6th, when you cut that exponent in half, is y to the 3rd. And this up here can't be factored because it's got a plus sign. Okay, so that would be your final answer for now. This one right here is absolutely fine. As a math teacher, I couldn't just leave that unfactored though, so I had to keep going. Again, week 9 notes, we're going to be looking into factoring completely, which is exactly what we just did right there. So don't stress about it for now. As long as you get the idea of DOPS down, you're doing great. You can go ahead and pause the video for a second and give 252 a try on your own. Okay, since you're paused, I'm going to go over it. So 25x squared plus 16. The first thing you want to do is see if it has a GCF. It does not have a GCF, so I move on to DOPS. You want to see if it follows the DOPS setup. D stands for difference. This one is not a difference. So this is actually not DOPS. If you paused it and you did it using DOPS, I intended on tricking you because I want you to recognize the setup. If it doesn't have subtraction, even though those are both perfect squares, you can't do DOPS. It's so important that you recognize the setup before you continue on. Like I said earlier, it's not about how to do it, or I'm sorry, it's not only about how to do it, it's also knowing when it applies. If you did factor it as though it was this with a minus, you should have gotten 5x plus 4 and 5x minus 4. So for 25x squared minus 16, this was the correct answer. For this one up here with a plus, you can't factor it. You leave it as is. So again, if you factored it as though it was a minus sign and you got this, you did it correctly, but this was not the correct answer for this example because it was a plus. It couldn't be factored. Okay, so just a recap. Again, so far we've done GCF. GCF can be done with any number of factors, any 2 factors, 3 numbers, 4 numbers, whatever it may be. It doesn't matter how many terms. GCF applies as long as there is a GCF. And you always want to see if there's a GCF to start. If there is a GCF, the GCF method applies. For DOPS, you want to worry about the setup. If you have the subtraction of perfect squares, the DOPS method applies. If it does not, then you cannot do DOPS, just like that last example we did. Okay. At this point, I'm going to give you the code word that is going to give you credit for watching today's video. The code word is donkey. Okay, so just write that down somewhere for yourself. For the week 8 notes, your code word is donkey. Okay, take note of the time stamp that we are on as well. Okay, so code word, donkey. What a fun code word. All right, moving on to our next type of factoring. It's so easy to know when you're supposed to do grouping, but it's a tougher method. You're going to do grouping when you have 4 terms. And that's really all there is to it. So again, the to-do is in this box. I'm going to walk you through how to do it myself. So if you look at 253, you have 1, 2, 3, 4 terms. That tells you right off the bat that you're going to use this grouping method. So you start by grouping your first 2 terms together and your second 2 terms together. Okay. That word grouping is supposed to help you with that first step to know to do that grouping step. Now this looks like distribution. It is not. What you are going to do next is pretend your second group isn't there and just focus on your first group for now. And you're going to use GCF within each group. I know it seems kind of crazy. That's why you want to be so good at GCF, is because it's going to be used continuously throughout. Okay, so for my first group, my GCF is going to be 4R. So I'm going to GCF my first group only by dividing both of them by 4R with a parentheses. Remember, this is the first type of factoring we learned on this notes. When I divide, these 4's cancel, R's cancel, and that leaves me with an X. Okay. Now 8R divided by 4R, the R's cancel, and 8 divided by 4 leaves me with a plus 2. Now I've completed the GCF of my first group. I'm going to move on to my second group. Between 3X and 6, my GCF is 3. So I know this is going to look a little funny, but you want to write it right next to that other set of factoring. So I can't really show you, but try to cover it up if you need to and pretend you're only factoring the 3x plus 6. So the 3 comes down, and then you have parentheses after it. These 3's cancel and leave you with an x, and then 6 divided by 3 is 2. Now what's really, really, really nice about the grouping method is you have like a halfway checkpoint. This right here and this right here must match. If they don't match, you took out the wrong GCF. You divided wrong. Something happened to make those incorrect. They must match up. If they match up, you're actually ready to write your answer. So here's how your answer stems from this. The thing that I just underlined, that x plus 2, is going to come down in your answer, but only once. Once you have that, those are gone. And look at what you're left with, 4R and a positive 3. That's what's going to make up your other factor, 4R plus 3. This is your final answer. So I'll say that again, where the answer comes from, and then we're going to practice a bunch more. So the x plus 2 is what they had in common. That comes down in your answer once. Then you look at what's remaining, what came from your 2 GCFs, a 4R and a positive 3, and you put them together in one factor of 4R plus 3. Now that can be checked. I'm not going to waste your time and show you the check because it's the same method of the check that we did in the DOPS method. If you want to look at my answer key and see all of these checks and how to do them, you are absolutely welcome to. Okay, so 254, I count 1, 2, 3, 4 terms, so that tells me right off the bat I have to use the grouping method. So I group my first 2 terms together and I group my second 2 terms together. Notice for the last two examples where I start my second group. See this right here I'm highlighting over? It's in front of the plus sign. The plus sign should be in your second group. Same thing here. When I have this parentheses made right here, the plus 7y is all included in my second group. You want that sign, this right here, to be included in the group after. All right, now I'm going to do exactly what I did before, and I'm going to GCF my first group, GCF my second group. So I start with my first group, x, y, and negative 7x. The GCF between those is x, so I'm going to divide each of them by x, and then I bring that x down. And now I follow up with my division. X divided by x cancels, which leaves me with a y, and these x's cancel and just leave me with a minus 7. Now I go on to my second group, 7y and a negative 49. The GCF between 7y and negative 49 is just 7. So I bring that 7 down, and I do my division. These 7's cancel and leave me with a y. Negative 49 divided by 7 is a minus 7. How do I know I'm right at this point? Try and think of the answer to yourself or answer me out loud. It's fine. These match up, which tells me I'm correct. It's a huge, huge step, and it's so very important. So because they match up, what you do is you bring it down in your answer, y minus 7. Only once. But now those are gone. Look at what you are left with, an x and a positive 7. Those come together, x plus 7. A question that I usually get during class at this point is, am I allowed to write it as the x plus 7 first and then the y minus 7? Absolutely yes. Both of these are correct answers. It does not matter which order you write them in. You absolutely must have the x in the positive 7 and the y in the negative 7 in the same set of parentheses though. Okay, try 255 on your own. I'm just going to keep on moving and doing this example. You should pause it at this point and give it some practice on your own. Okay, take that initiative and pause it. It is grouping because there's 4 terms. So I group my first 2 terms together and I group my second 2 terms together. Now the GCF of my first group is a little bit tougher, but I look at my numbers first. Between 3 and 6, my GCF is 3. Between x cubed and x squared, remember x cubed is x, 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 3 of them. X squared is 2 of them. It's kind of a difficult concept, but look, they both have 2 x's in common. So part of your GCF is going to be x squared. It has to be the greatest common factor. So x squared is the biggest variable that can be taken out of each of them. Okay, so that 3x squared comes down, followed by parenthesis. These 3's cancel when you go to divide, or in other words, leave you with a 1. And then think about that same idea with the x's. If I have 3 x's divided by 2 x's, these cancel, and leave me with 1x. Okay, negative 6 divided by 3 is a minus 2, and x squared divided by x cancels. Just like it did over here. If I have 2 on top and 2 on the bottom, everything cancels. And I close my parentheses. Now my next group has 2x and negative 4. Much easier to find the GCF between those two because they both don't have a variable. It's simply 2. So when I bring down that 2, followed by parenthesis, I then divide. 2's cancel and leave me with an x. Negative 4 divided by 2 leaves me with a minus 2. Again, I'm going to keep asking this. How do I know that I'm right at this point? Great answer. These match up. X minus 2, x minus 2. They're the exact same, so I'm good to write my answer. Because they match up, I'm going to write that in my answer, but I only write it once. Oops, I wrote plus. Sorry, guys. I just love positive numbers. Okay, so x minus 2 comes right down. And then you take what you are left with from your GCFs, and those come together. Come together. Just like that. Final answer. All right, next one is a little bit tougher. I know I have 4 terms, so I know the grouping method applies here. When you go to make your groups for this one, be very careful. Parentheses around the first 2. Make sure you get that negative inside of your second group. It should be a negative 4n within the second group. What's kind of nice about factoring, guys, is the method doesn't really change. Once you know how to do grouping, you just keep doing it with different numbers over and over and over. There's not really much thinking once you get the process down, but practice makes perfect, guys, so please do these examples and work on your homework as well. Okay, so I have 3np plus 15p. I need to find the GCF between those two numbers. Between 3np and 15p, my overall GCF is 3p. So I'm going to divide both of them by 3p and put that 3p out in front to show that. So my 3's cancel, my p's cancel, that leaves me with an n. 15p divided by 3p is going to be a plus 5 because the p's completely cancel. Now, my GCF over here, please stick with me for this. Even if you think you got it down, just focus on this part because it is a little bit more challenging than the last few. Negative 4n minus 20. Between 4 and 20, my GCF is 4. If you take out a 4 and you divide, negative 4n divided by 4 is going to leave you with a negative n because it's a negative divided by a positive. Right away, hopefully you're noticing these aren't matching up, so we have a little bit of a problem. If you keep going with this though, and you didn't notice right away, negative 20 divided by a positive 4 is a negative 5. Notice between this and this, the only difference is the signs. I have the n's and the 5's matching up, but in the first group they're positive and in the second group they're negative. That's still a big no-no, so that's not going to work. But try to think about something that you can do to make that change. When I divide this right here, I was dividing by a positive. That doesn't change the sign. If you divide it by a negative, watch what happens. Okay. Negative 4 divided by negative 4 is going to get me a positive n. Great start. Negative 20 divided by negative 4 gets me a positive 5. That's perfect because at this point they check out. So if you knew right away that this was a negative, so that this needed to be a negative, awesome. If you forget and you take out a positive 4, you're going to go through that exact thought process that I just went through with you. If you take out a positive 4, these don't match, and that tells you right away something's wrong. Because they almost matched, they were only different with the sign. Hopefully that reminds you that your GCF needs to be negative. Now at this point, because they match up, the n plus 5 is going to come down. Those are gone. Now my 3p minus 4 also comes down. 3p minus 4 all together. The only difference is because this was a negative, this negative also comes down in your factor. Remember, all of those can be checked. Okay, that's where I'm actually going to stop for the first half of these notes. We'll move on to the second half of the notes in the next video. Hope you enjoyed. Try to work on the homework assignments at least up to this point, or if you want to just jump into the next video because you're feeling like you're on a roll, absolutely go for it. Factoring is a lot to take in, so maybe breaking it up a little bit will help. Go get yourself a donut or something to power yourself through and get through this all. Okay, remember that the code word for this video, I'm not going to say it again just in case anyone skipped to the end, it's somewhere in the middle. You can go back and find it. Okay, but we will pick up right on 257 in the next video.